So with that said, I'll go ahead and put the fries in the bag. Let's jump in. Right? Cool. So we have a race car traveling forward, and we're increasing. What I need to know, and am just dying to learn right now, is what do we know? And I'm just going to call a bunch of random people. About half of you did the problems, which is sweet. Number 8, can you give me one thing I know?
The race car travels forward and increases from 4 miles meters per second.
Okay, so how would you have me write that down on my known stuff? How fast is it going at the beginning? And give me a better way to say or write down how fast it's going rather than the words. So careful. No, and that's okay. Thank you for volunteering it. Delta T is a change in time. This measure, meters per second, if you look back, and I already moved screens, what do we measure in meters per second? The velocity. Now, I know at this point, my initial velocity is 4 meters per second. And I'll put the slash, or the dot. Also, I didn't notice it yesterday. I promise I know how to spell the word increases. I just saw it when I was reading back through it. All right. What else do I know? Number. I'm just going to get the list so I can look at names because I'm never going to remember. Kalisha. What else do I know about this? I know the initial velocity is 4 meters per second. What's 36 meters per second? So good. And so with this, always the hardest part, at least when we're starting these initially, what do I put on the left side? What is equal to 36 meters per second? One more time, I'm sorry. So not x, careful. If it's just x, it would just be position in meters. If it's meters per second, it's a speed, but speed's not the real thing we use. Starts with a V again. Velocity, but it's which one this time? Final. All right. Now, I've got this knocked out, my initial, I got my final. One more little piece here. That is a measure of time. We could do TI and TF if you wanted. Could we just call it time in general and just know that we're starting at 0? Okay. How much time do we let elapse or pass? 4 seconds. All right. That's it. What do we ask to find? Average acceleration. Now, when we go through here, this, as long as we have the formula, it's just plug and chug. I would encourage, as you go through, I can pass out note cards earlier if you'd like. What would be a good idea is as we get more and more kinematics equations, if we just keep a running list as you go through the chapter, it means that you'll always have just a little note card that you can look at while you're doing your homework and stuff. And you've already knocked out a big part of your test prep stuff because you already have a note card started. How do you find an average acceleration though? So instead of delta V, you're right though, I'm going to write this over T, yeah? Delta V over delta T. And then all I've done is instead of writing delta V, I just wrote out what it is because I'm going to use it anyway. At this point, do you know VF and VI? Do you know T? So welcome to, I don't even know if I'd call it algebra yet, but let's check. What's VF? 36 minus 4. And then over here, I'm going to include my meters per second. And divided by, how much time passes? 4 seconds. Tell me what's wrong. Oh, sorry, I missed. Can I do that? Why? Yeah, it's like there's a whole lot of different ways you might word this. We need to look at it. It doesn't really show up, but that's grouping in the numerator and denominator. Deal with them first. So 36 minus 4, I think is 32 over 4. And that simplifies, I believe. Equals 8. I'm going to write this a little bit smaller. Equals 32 over 4 equals 8. And meters per second, is there a more convenient way to write that? Meters per second squared. And check it out. Final statement. Lazy but correct sentence. How do you write it? The average acceleration is approximately 8 meters per second squared. Now, that's not approximately. That should be equal to. I'm just going to say is because we actually found the value. Now, going through this, if you have the equation, it shouldn't be too crazy to try to solve. I want to do some more practice problems though. So we get a decision. Do you want to do a bunch of practice problems together? Do you want to try a few on your own so I can get a gauge to see if we should move on to the next section first, on your own first? Okay, so I'm going to give you guys some time to work through the following in class. I'm cool with having a kind of chill day as long as we're all on task. Right now, I want you to try, and these are fine in your notes, examples. And then I would write it as page 67. And I want you guys to try 6 through 10. As we're going through here, 10 says it's a challenge. I wouldn't necessarily believe it. Don't trust their language with it. Let's try these, see how it goes. We'll work through some. I'll give you like 15 minutes or so. Try to come back together about 9 o'clock to discuss any issues that we might have. Cool. When you're setting up problems, I would strongly encourage knowing these things and being able to start the problem by doing this is going to be, I would say, the most important or fundamental part of you solving these problems. Some people can do this without ever writing anything, and I totally get it. I'm going to sound like a broken record, but that's fine. That's fine. We're going to go ahead and just make sure every single time we make use of this, because as problems get harder, you will get lost. It's coming, I promise. Now, I can just check this out really quick. If I do 15 minus 36, that's negative 21 divided by 3 is indeed negative 7.0. And you don't see me playing the unit game, but it's happening. Number 8. Just kidding. Number 7. What's the acceleration that you guys found on number 7? Negative 8.3 meters per second. Careful. I'm okay with that with one exception, possibly. I assume that you just picked their first direction as negative. Am I wrong here? 0 minus negative 25 over 3. I wind up getting a positive. Now, that doesn't change necessarily. Don't change your answer real quick. If you have your initial information written, why did I elect on number 7 to do... Whoa, why did I elect to do negative 25? I know why I did. Why did I do negative 25 on number 7? It's moving west. If you didn't call it negative 25, that's okay. If you just said regular positive 25 and just said west is positive, which is a good way to do it, you are going to get a negative acceleration instead. Whether it's positive or negative determines on your reference that you used, but we are shooting for 8.3 meters per second squared. In mine, if velocity is negative and I'm slowing down, acceleration better be which direction? If I'm walking that way, which way does acceleration shove me to slow me down? The opposite direction to make me go slower. In my situation, it winds up positive. Whether you're positive or negative, can we all agree that's 8.3 meters per second squared to the east? And that's going to clear up any confusion with positive or negative that we have to deal with. As long as you're consistent with what you use, we all have east. All right, what if you double the time? What happens with it? It's half of it, right? So 4.2 or 4.15 if you wrote it all. Cool. All right, number 8. Here it is. Do you have the same things, negative and positive? Because if they're both negative, you're in trouble. If they're both positive, you're in trouble. Not like literal trouble, but trouble with solving this. They're rolling backward, and then they'd start their engine and then start moving forward. These ones are a little bit uglier. 7 divided by 2.5. That's not a nice number, is it? It rounds to a nice number, though. What do you get?
Well, isn't it 7.5 divided by 2.5?
It is 7.5 divided by 2.5, and that's a much nicer number. 3, right? I missed the 0.5. Thank you for that. Okay, and let's check direction. Better be positive in mine. Squared. 3. Baller. Number 9. Looks like it's going to be ugly and maybe a little bit. Negative 2.75 divided by 10. That's not really that bad. Negative 0.275 meters per second squared. I'm going really fast with this. This one's the ugliest I think that we had. 0.75 minus 3.5 over how much time? 10. So I know that that is negative 2.75. And then I don't need a calculator because divide by 10 just moves the decimal where? 1 to the left, negative 0.275 meters per second squared. All right, 5 through 9, just like completely honest. Yay, went really well. Ugh, I hate it. Somewhere in between. Okay, so number 10 looks like it's a challenge, but it's not. The language is just kind of ugly. I'm going to save these here. I'm going to write 10 up here. All right, what do you know on 10? Just help me out. Okay, what's the initial velocity? 1 what? Okay, so is this right now, do they just use Y? They do. Is this in SI, like standard units? Do you want to change it to meters per second? Good, me neither. What's the final velocity? 0.5 centimeters per year. Now, before we do anything else, are you expecting a positive or a negative acceleration? Why? How can you tell without doing any math? It slowed down, and we said it was moving in the positive direction. And we're trying to see the average acceleration, right? So here's a really handy thing. What's your delta t going to wind up being? 1 year. Can you guys subtract? Boom. What's 0.5 minus 1? Negative 0.5 centimeters. Ooh, what's the unit on it? Centimeters per year squared. Negative 0.5 centimeters per year squared. Okay, these ones, hopefully not super challenging. If they are, I can certainly work through like other problems with you if you'd like. The other thing that I'm going to start doing, if you all promise to take notes, I have no issue with it. I will start posting the whole section's notes on the classroom as well, so that if you want them maybe more organized than you have them, they're there for you. Cool. You have to keep taking notes in class. If you want to print them, let me know. I'll have to switch the background back to white so that we don't waste like a ton of ink. All right. What are 3 ways an object can accelerate? Positive? Negative. And there's one more that I don't think we like spoke about directly. We're on the Earth, I think. Feels like we are. Right now, stay as still as you possibly can. Are you accelerating? From our perspective, are we accelerating right now? No. How about if we look at the whole Earth? The Earth is doing what all the time? Spinning. Now, I'll tell you, the Earth spins, and we'll just work under like perfect assumptions. We're going to make this claim. The Earth spins at a constant speed. Okay, it's just the same speed all the time. Is the Earth accelerating? So all of you just make me. Right now, oh, I get real dizzy real fast. I'm going to go really slow. Here's me spinning, right? I'm the Earth. Look at me. I'm awesome. I'm going to get dizzy still, I promise. Am I accelerating right now? What do you guys think? I'm going to go the other way to fix it. You say no. I claim yes. Why? Why am I accelerating right now? Holy, direction changes. Remember, velocity is speed with a direction. As soon as I change my direction, like even right now, as I'm walking at 1 meter per second, 1 meter, 1 meter, 1 meter, 1 meter, turning, 1 meter, 1 meter, 1 meter. My speed was the same everywhere. But did I change direction? And because I changed direction, what also must have changed? My velocity must have changed because direction's half the battle with it. Okay, forward, or positive, negative, and directional. Those are the 3 different ways that we can accelerate through something. I have a worksheet for you. And we're going to get started on it. I'm not going to record anymore. Smash the like button.